Hello, YouTube. This is Umozo3. So now we've already had 5 lessons in regard to object-oriented programming, right? In lesson 33, we introduced the fundamentals of object-oriented programming. We looked at constructors and instance variables and class variables. In lesson 34, we talked about inheritance and the concept of subclasses and how subclasses can accept functionality from a superclass, but they can also come up with their own or modify the functionality that they inherited from the superclass. And we also said that there can be multiple subclasses to the same superclass, and also that a subclass can then in turn be a superclass to another subclass. So hopefully that's sort of multiple inheritance, those multiple layers make sense to you. And then in lesson 35, we talked about the string representation of an object, and we said that we have a function called str with 2 underscores before it and 2 underscores after it. Then that's an instance method that allows us to return any string representation that we want for a particular instance. And hopefully, perhaps we would seek to invoke the values of the instance variables for that particular instance, some identifying information that's unique to that instance, right? So, some specific things that are particular to a particular instance, right? That would distinguish it. And then in lesson 36, we talked about dunders, which are special functions that basically allow us to apply simple arithmetic or Boolean operations to instances of a class that we make. So what we're going to do is see an example of dunders in this class, and we're going to talk about a new concept in this lesson. But then in lesson 37, we talked about basically the keywords del and pass, and we said that del is used for garbage collection if we no longer need a particular variable to keep hold of a particular value. We can remove the value from memory, and then that would free up memory in Python. And that can be useful if we're talking about big, serious data structures that hold a lot of objects, right? That hold a lot of data of particular types and whatnot. And so if we don't need some of that information anymore, it's nice to know about the theory of garbage collection. So that was discussed previously. And then also the pass keyword, right? And then we also saw a couple of other cool dunders, right? So we're also going to see an example of the get item dunder. Remember that we can treat an object as though it's a dictionary, okay? And basically we can specify different keys, and we can specify what kind of a value we would want to have returned if we put a key into our dictionary, right? And so here, the dictionary is basically, it's the analogy of our instance, right? We're basically turning our instance, we're formulating our instance as a dictionary that we can go ahead and pull values from. So then this specifies the behavior of x of name, right? For some instance x of the person class. So this is basically what would be returned. So this tells Python that x of name, if we put in that particular key, should return the name instance variable. And you might be wondering what those underscores mean right there. And we're going to talk about that in this video, okay? So basically, we have a person class here, okay? And we have 2 class variables. This is very similar architecture to what we had back in lesson 33. And we said that it's going to be important for you to get into the habit of making doc strings. So you would go ahead and have a doc string. So you'd have a multiple line comment underneath the header for this constructor, which would basically say something like constructor, which assigns the name and age instance variables to the parameters that were passed in, okay? But basically, we're going to talk about these underscores, and we're going to talk about something in this lesson called encapsulation and data hiding, and basically the idea that sometimes you want to keep information specific to a particular class, and you might not want all of the values or the information with it for a particular instance or within a particular class to be accessible outside of the class. And you can think about why that might be important. Maybe there are, concerns of, privacy, okay, or data hiding, right? You wouldn't want everyone's Facebook, you wouldn't want everyone's phone numbers and addresses to be accessible on Facebook unless everyone in the world had voluntarily agreed to provide that information, which I can guarantee you most people have a problem with, right? But we can go ahead and think about that in the context of this video. But go ahead and just ignore that for now. So just ignore that. We have an income class variable, right? These are class variables because they apply to the class in general. And we said that particular instances can also have values for those class variables. And we might have a method called work, which we talked about in lessons in 33 and 34, right? Which we talked about in 33 and 34, which would basically allow us to update the value of the class variable for a particular instance. So this treats income as, so this basically allows income to be not only a general class variable, which stays at 0 for the general person class, but also which can be incremented for a particular instance, okay, for a particular example of a person. So hopefully that's clear to you, the distinction between person income and a particular person instance's income, okay? But hopefully that's clear to you. And at the beginning in the constructor, a person's instance, the instance income would be initialized to 0. It would basically take this value, and then it could change if the work function is called. But anyway, this constructor assigns name and age to whatever name and age are passed in. And you could have called these something different, right? Or you could have called these P and Q, but then you just have to make it consistent. So if you don't want to have any confusion about what name is what, right? So here we said that name on the left-hand side is the instance variable. Name on the right-hand side was that name parameter that we had there 30 seconds ago. But now we could just say P and Q if you want to avoid the ambiguity. And hopefully now it's just clearer to you. It's just a direct assignment of the two things that were passed in. Name is what's going to be passed in first, and age is what's going to be passed in second. And then we have a void instance method, okay? And we've seen this already, and just ignore the underscores. We'll talk about that in a minute, but it's just going to print something on the console if we apply the work function to a particular instance of the person class. And it's also going to increment the value of the instance variable income for that particular instance by 10,000. Okay, so if it was at 0 for that particular instance, it'll go to 10,000. If it was at 60,000 for that particular instance, it'll go to 70,000. So hopefully that's clear to you. We're also going to have two functions called speak and fly, and I have more examples, more practicing, so that you can be exposed a little bit more to exceptions, which we talked about in lessons 17 and 18. We have a speak function, which is going to try to be applied to an instance. So you could say for a particular person instance X, you could say x.speak, right? And you would call it with empty parentheses, because we've been saying over and over again that here self is not an input. Self is an indication. It's a symbol to Python that this is an instance method that applies to a particular instance. Okay, but it's going to try to assert that self.can speak. So basically what we're going to do is we're going to try to check to see if that Boolean is true. Remember, if we try to assert something, then the program will continue running if the Boolean is true, and it'll throw what's called an assertion error. This is a type of exception, an assertion error, if the Boolean is not true, right? True, keep going. False, throw an error and stop the program. Okay, that's called an assertion. And you can see why that might be useful, right? If you want to make sure that something is true before before something proceeds, right? You check someone's ID and you assert that they're at least 21 before you let them into the bar. Otherwise, you throw an exception, you call them out. You say, oh, I can't let you into the bar, right? You throw an error, right, in the program of what they were hoping to do. So anyway, that's kind of the real world analogy, but essentially we're going to try to assert that they can speak, right? And if you look up, we have a true value for the can speak class variable. So that shouldn't be a problem for a particular instance. So we should be able to print, yep, I can definitely speak. And since this is a true Boolean variable, we will skip the exception. So we will not run the exception block. We will just go ahead and say, yep, I can definitely speak if we call speak on a particular instance of the person class. With fly, it's awfully similar, right? It's literally the same architecture. Here we're checking the can fly Boolean variable. We would print something different, and then we would raise basically a different type of message if there were an assertion error. So basically what I'm saying is that if there's going to be an assertion error, I want you to have that assertion error, because we could divert the program, right? In lessons 17 and 18, we said that we can catch an exception, right? We can catch an error, and we can say, instead of throwing an error, I want you to just print something alternatively. But here we're saying, instead of throwing an error, I actually want you to throw an error, but actually throw an error message as well. Okay, so it's just kind of attaching that on. So hopefully that makes sense to you. But here, this self.canFly, that's not going to work, right? That's false. And if we assert false, then we throw an exception. We throw an assertion error. And so instead of saying I can fly, we're going to say this instance cannot fly. Okay, so hopefully that's clear to you. And then we have a less than dunder. Okay, so here what our dunder is going to do is it's going to look at this, person instance that we're, talking about, that we're acting on, as well, x less than y. So we'd be looking at two person instances, x and y. So we'd be passing in y essentially to this function. And so basically I would say if that x is less than y, if the age of x is less than the age of y. Okay, so hopefully that's clear to you. And then greater than would just be the opposite. I would say x is less than y if y is less than x, according to my definition of less than from this dunder. Okay, and we talked about dunders in the previous video. We talked about dunders like this in lesson 36, and I think maybe a little bit in lesson 37 as a review. And then we have basically a get item, right? So I think we already talked about this, where we say if I want x of name, then it would return the name. If I want x of age, it would return the age. If I say x of speak, basically that it wouldn't return anything, but by basically making that assignment, by setting something equal to x of speak, it would call the self.speak function. Okay, and the same thing would happen for fly. But we're going to test all that out. But before we do, I wanted to tell you about basically this underscore. Okay, so basically, if a variable has a single underscore in front of it, it is a weakly private variable. Okay, this means that it is a variable that other classes are discouraged from using, but still can use. Okay, so here basically name is a weakly private variable. And here basically says, oh, that means, oh, well, I wouldn't really want you to call on that value directly for a particular person instance from outside of the person class, but technically it's not going to be illegal to do so. So let me show you what I mean by that. I already have a couple of examples here. What we're going to do is we're going to create a person object where we initialize the name instance variable to Abby and the age instance variable to 42. And then what we're going to go ahead and do is we're going to try to print the name of Abby. And you can see there's already a Python enhancement proposal here. And so we can go ahead and scroll over it. And it says access to a protected member name of a class. And so basically Python doesn't love that you're doing that. And basically it's called a weakly private variable. And basically it basically means that it's like data discouragement. So it's like when programmers try to call the name instance variable from outside of the person class, we're going to let them know that the name instance variable is weakly private. So we can use it in the context of the class as much as we want, but we don't love the idea of people using it from outside of the class, but it's not forbidden. Okay, so this would go ahead and be okay. And then what we can do is we're just going to go ahead and try that one line of code for now, so you can ignore this other stuff, but it's able to print Abby, right? Because that was the value of the name instance variable after we called the constructor and assigned name to Abby and age to 42. What we can also do is we can go ahead and review our understanding of dunders from the previous video. Remember what the get item dunder does is it allows us to treat the instance as though it's a dictionary that we can type a key into. And so all we need to do is specify a key, and we say if we type in name for the key, then we need to return the name instance variable. And so this is going to have the exact same effect according to the dunder that we wrote. So hopefully that's clear. What we're going to try to do now is we're going to try to print the value of the age instance variable, because we said that the age was initialized to 42, right? You can see that in the constructor, but you can see two underscores here. So what we're going to try to do is we're going to try looking at basically the value of this instance variable, and we're going to see if we're going to be able to print it. So we're going to run the executable Python file, and it says that the person object has no attribute age. And so basically this is what's called a strongly private variable. Okay, if a variable has a double underscore in front of it, it is a strongly private variable. This means that it is a variable that cannot be called directly, or accessed from other classes. Okay, it can only be referenced or returned within the class in which it exists. Okay, so here, if you're going to talk, you can assign the value of this strongly private instance variable to anything you want. Okay, and then you could go ahead and return. You can go ahead and return the age if you talk about formulating the instance as a dictionary, but you cannot go ahead and try to, you cannot directly call the age instance variable like we were able to call the weekly private name instance variable in line 60. But now you can already see it's highlighted in yellow. You can see it's an unresolved attribute, and we already ran it, right? And we saw that that was an issue. So we're going to comment out that line of code. But now what we're going to try to do is we're going to try to print A of age, okay? And we said that if we treat this instance as a dictionary and we type in the key age, then it would be able to return the value of the instance variable. So let's see if we can figure out how old Abby is. And indeed, this works, okay? So using get item is one way to return the value of a private instance variable. What's another way you could do it? Well, we're going to look at another way, but in a future video, we're going to talk about something called getter methods, where we can simply just return the value of an instance variable. And why would we want to do that? You could also have, we also could have implemented an str method, right? We could have said, oh, their name is, and then their age, and then years old, right? And then if we had wanted to print a particular instance, it can still go ahead and return the value of a private instance variable by calling str, right? You can still call str, but you cannot call directly on a strongly private instance variable. So hopefully that's clear to you. We can go ahead and try a.speak. So this is a void method. Remember, this is going to go ahead and check out. We looked at this earlier, and since self.can'tSpeak is a true Boolean, we'll be able to run, this line of code 26, and we'll skip the exception. Okay, so we're not going to throw an exception. So what now we're going to do is run main.py, okay, and say, yep, I can definitely speak, right? And then what we can do is we can try saying something like, what if we tried something like k equals a of fly, k equals a of fly. So let's go ahead and look at that again. So what we're doing is we're looking at the get item dunder, and we say that if we specify the key of fly for a particular instance, then we call the self.fly method, right? And so we would return nothing, right? We return nothing at all. We simply just call self.fly, right? So we wouldn't want to print k at this point, right? This would print none. This is a null object, and we talked about that previously. But simply by making this assignment, it's using this dunder, right? And it's running these two lines of code. So we go ahead and look at self.fly, and here we throw an exception where it says that this instance cannot fly. That's what we told it to do in the fly function. And indeed, it says that we get an assertion error, and we get that message. It says this instance cannot fly. So hopefully that's clear to you, what happened as a result of that line of code. What if we create another instance of the person class? So we say person of Scott and 39, and we try printing whether or not A is less than B. So here, if we take a look at the less than dunder, this is comparing the age instance variable, and age is a strongly private instance variable, has 2 underscores before it. So remember, we're saying that a strongly private instance variable cannot be specifically accessed or called on from outside of the person class. You can see that this person class definition, it starts up here on line 1, and it goes all the way down to the last thing in the person class definition is this get item dunder. Okay, 55, line 55 is pretty much the last line of the class. And these lines of code don't belong to the class. So you cannot directly call a.age. The only way you could get the age instance variable from the code that we've written is to go ahead and return it, and that's to use the dunder. Okay, so the dunder is really what makes the age instance variable accessible from outside of the class. So hopefully that's clear to you. But we can try to print the result of this Boolean expression, which we defined in the LT dunder. Remember, if you do define underscore underscore LT underscore underscore of self comma other, then you can specify what the behavior of one object less than another object belonging to the same class would return. How would that be defined? And it says false, right? Because 42 is not less than 39. That was our definition for it. And right, and then now we can have one more example. So what we're going to do is we can go ahead and remember the definition of pass, right? So pass just goes ahead and reads the line. It says it's a null operation. Nothing happens. It's a placeholder when a statement is required syntactically, but no code needs to be executed, okay? So it would just read that, and then it would go on to line 70. That's a review from the previous video. But we can say, well, if there's an assertion error, then we can say, well, don't try to get B of name. Who's B of name? Well, that would go ahead and reference Scott, because that's the assignment that the dunder makes. So it would say, don't try to get Scott to fly, right? Because here we would try to be making Scott fly. But if there's any assertion error, if there's going to be any problem in that code, we're going to catch the exception. We're going to catch that particular type of exception, and we're going to run this line of code instead. Okay, so now if we go ahead and run it, hopefully it's clear to you what we're going to get. So it says false, and then it says don't try to get Scott to fly, because that's how we specified these functions to work. So we're combining our understanding of dunders, instance methods. We've talked about private instance variables. Remember, a weakly private instance variable is an instance variable that other classes are discouraged from accessing. A strongly private instance variable is an instance variable that other classes are prohibited strictly from accessing. So hopefully that's clear to you. We have about 2 or 3 more lessons of object-oriented programming, and we're almost done with the curriculum. So from UMLS 03, thanks for watching, and please subscribe.